Good morning. We are going to go through last night's homework. That was the homework 11.1 and 11.2. And I'm just going to jump in and get going on this. Find the area of each figure below. The easiest way to split this one up is to think of it as a whole big rectangle missing a smaller rectangle. So the small rectangle, easy enough to find. Area equals base times height. 9 times 5, that has a little area of 45, which I'm going to subtract from the big area, which is 14 by, we've got 11 plus 17, 14 times 18, 14 times 18 minus that 45. 14 times 18, well, 16 squared is 256. This is 2 away from either side of 16. So 2 squared is 4, and I should get 256 minus 4. I should get a 252. Makes some sense. 4 times 8 is a 32, so it's definitely going to end in 2. I like that. Minus that 45 degrees. I think I'm going to end up with 207. Said 45 degrees in there. Sorry, I'm still thinking circles. Likewise over here, I'm just going to complete the big rectangle. So this is 8 plus 4. The whole bottom of this thing is 12. This is 5 plus 3. The whole side is 8. So the area of the whole darn spanking thing should be 96, minus that 3 times 4, minus 12, and minus 3 times 2, minus another 6. 90 minus 6 is 90, 90 minus 10 is 80, and minus another 2 brings me down to 78. Find the area of each rectangle. I'm going to be a little bit better and write down the formula this time. Area equals a base times height. They did tell me that it is a rectangle, although honestly in this section, if it looks like a rectangle, it is. If it looks like a right angle, it is. Breaking the rules of geometry a little bit. So I see an 8 as 17, remembering way back to chapter 9, we've got an 8, 15, 17 triangle. Well, the base and the height are 8 and 15, or 15 and 8. It doesn't make any difference. So 8 times 15. I don't know how to multiply by 8, but I do know how to multiply by 2. To multiply by 8, just do that 3 times. 15 times 2 is 30, times 2 is 60, times 2 again is 120. The perimeter is 40 and one side is 6. Well, if the perimeter is 40, the semi-perimeter is 20. And the semi-perimeter is one of the bases and the height, or the height and the base, again, depending on how you look at it. If that adds up to 20 and I already have 6, this other one must be 14. So 14 times 6 is 28, times 3 is 75, plus 9 should be 84, I believe. And again, looking at the last digits, 6 times 4 definitely ends in a 4. So that seems legit. In my hand, I have the right looking book, but the wrong book. Here it is. And so 4A is on page 513. Let's take a quick look at that guy. 513, number 4A. The area of a rectangle is 48. Okay, and the altitude is 6. So if this is 6 and the area equals 48, again, that 48 equals the base times the height. So I'm really dividing, and I'm going to get 8 in here. I think they were a little bit more specific and gave me units this time. The units of area are, of course, in square millimeters, meaning these would presumably be in millimeters. Find the length of diagonal, well, no fooling us. That looks like a 6, 8, 10 millimeter triangle, which I guess that's the 4B that goes over there. Find the area of each shaded figure, assume those right angles, and so again, I am going to just say it's a big rectangle minus a small rectangle. 7 plus 5, there's a 12. 12 times 12, that is 144. Also, I have a, well, if that's 4, then this is 8. I have a rectangle with an area of 40, which I'm subtracting, and I'm going to get 104 over here. Same idea for this one. The full rectangle has a base of 4 plus 4 plus 6, a base of 14, and a height of 9. That is like 140 minus 14. That is like 130 minus 4. That should be 126 minus that 24. I think we're looking at 102. Okay, over here, we've got a 20 by 10. We have a rectangle with an area of 200 minus a 6 times 14. That is going to be 60 plus 24. We're looking at 84 over there. We're looking at 120 minus 4. We're looking at 116, I believe. Okay, not so rough, not so bad, not so shabby. 7a, gotta look at the book again. Find the diagonal of a rectangle is square root of 29. So you are square root of 29, and the rectangle's base is 2. That looks more like a 2, so I'm calling that the base. A little bit of Pythagorean's theorem here, which of course says a squared plus b squared equals c squared. That is 2 squared plus really the height squared equals 29 squared, square root of 29 squared. So 4 plus h squared equals 29. H squared equals 25. Looks like my height is 5, and therefore my area is going to be 10, base times height again. Okay, now we move on and start throwing some triangles into the mix here. Remember that the area of a triangle is base times height divided by 2. So the area of this rectangle is 3 times 7 is 21. It shares a base with the triangle. So the base is 7, the height is 4. So 7 times 4 divided by 2 is the same thing as 7 times 2. It is 14. And altogether, it looks like we've got 35. Over here, we've got a 3 times 3, a 3 times 4. This must be 3 times 5. So that is 15. The area of the rectangle is 6 times 15, which is 3 times 15 times 2. We got 90. I don't like this as a base because then I have to figure out what the height is, and I can Hoopy-Nachi style if I want. I much prefer to think of 9 and 12 as the base and the height, or the height and the base. It makes no difference. So 9 times 12 divided by 2 is the same thing as 9 times 6. It is 54, and I think we're looking at 144 as our answer there. Number 4, I gotta switch over to page 19, says the altitude of a triangle if its base is 7 and its area is 21. So without even drawing it, I'm going to say area equals 1/2 base times height. They told me that the area is 21. That should equal 1/2. Altitude is the same thing as height. So I'm looking for that base. I'm looking for the height. They told me that the base is 7, and I'm looking for that height or that altitude. Okay, multiplying both sides by 2, I get 42. Divided by 7, I get 6. 6 equals that height. Not so bad. The area of an isosceles triangle with sides 10, 10, and 16. 10, 10, and I'm not going to write 16. Instead, I'm going to write 8 and 8 because the median of a isosceles triangle is also the altitude. So I've got one of those blank 8, 10 triangles. This has got to be a 6. It is one of those Pythagorean triples that we know. And I could say that area of the whole triangle equals 1/2 its base times its height. That is 1/2 of 16. That's one of those eights there. Times 6. 8 times 6, 48. And number 7, find the base of a parallelogram of height 3 and area 42. So again, I'm going to start with the formula for a parallelogram. The formula we have is just base times height. They told me the area is 42 equals, find the base, so that's what we're looking for, and the height is 3. So I'm going to divide by 3. Seems like I'm going to end up with 14 there. Okay, find the area of each obtuse triangle. These ones are a little bit difficult. To find the area of the obtuse triangle, what I'm going to do is I'm going to find the area of the whole triangle and then subtract the little right triangle. So they tell me that this is a 30-degree angle, and in the big right triangle, that would be a 30, 60, 90, where opposite the 90 is 16. So opposite the 30 should be 8. And I'm going to call this bit 8 root 3. Okay, this is 8 root 3 minus 7, just to be complete. Rethinking it, I'm not going to find the area of the big one and subtract the small right triangle. I have a base, I have a height. They are perpendicular. I'm good to go. 7 times 8 divided by 2 is 7 times 4 is 28. Area equals 1/2 base times height. That is 1/2 of 7 makes a good base, and 8 makes a good height because they are perpendicular. And as stated, that is 28. Same idea over here, except they just give me what I need to know. 1/2 base times height. That is 1/2 of 10, which is perpendicular to that 12. 1/2 of 12 is 6 times 10 is 60. Okay. Hardest part of the homework, getting pages to separate. Find the area of each triangle again. They give me a 90 and a 60, so I know that's 30. If opposite the 90 is 12, then opposite the 30 is half of that is 6. And this is that one times root 3. Area equals 1/2 base times height is what I'm going to apply to all of these. In this particular case, that would be 36 root 3 divided by 2. That should be 18 root 3. If this is 12 root 2, it's a 45, 45, 90 triangle, so this should be 12 and 12. I should get 1/2 of 12 times 12, 1/2 of 144, which seems to me to be 72 in this one. This one is an equilateral triangle, which is isosceles. It's just more than that. So when I draw in that altitude, that height, it should bisect this side into 6 and 6, perpendicularly bisect this side. And that was a 60 in there. So there's a 30. Opposite 30 is 6, and opposite the 60 is 6 root 3. And I've got 1/2 of the base of this thing is 12, and the height of this thing is 6 root 3. I think I've got a 36 root 3 that I'm looking at. Okay, thought-provoking multiple choice questions. I will not lie. I went online and I typed in practice SAT questions and got these. So I thought they were good. They obviously go through a variety of different skills. So let's dive in and do them. 6 pints of a 20% solution of alcohol in water are mixed with 4 pints of a 10% alcohol in water solution. The percent alcohol in the new solution is, well, without doing any work, it's got to be somewhere between 20 and 10. All of these are. There's more of the 20 than there is the 10, so I think it should be leaning on the higher side. But let's give it an actual look here. Let's find out how much actual alcohol is in these 6 pints. Well, 20% of it is alcohol. So 0.2 times 6 is how much alcohol is in the 6 pints, plus 0.1 times 4 is how much alcohol was in the 4 pints, 10% of that 4 pints. So it looks like I've got a 1.2 plus 0.4, which is 1.6 out of 6 plus 4 out of 10 pints total. And 1.6 out of 10 is 16%. So yes, that is my answer. ASB is a quarter circle. PQRS is a rectangle with sides. PQ is 8, and PS is 6. What is the length of the arc? Well, I know I have a 6, 8, 10 triangle there. So I know that my radius is 10, and then I can do my arc length formula. Which says central angle, which is 90, over 360, which is the central angle for a full circle, equals that arc length, I'll call it L for length, over, well, the length for a full circle, which is, of course, the circumference, 2 pi r, so in this case, 20 pi. 90 over 360 reduces to 1 over 4, equals L over 20 pi. To go from 4 to 20 pi, I multiply by 5 pi. So I should multiply the 1 by 5 pi. 1 times 5 pi is 5 pi. No consistency. There's an X. There's a circle. Who knows what we'll do next time. This is a new operation to me, to you, to everyone. If X thing Y is equal to X plus Y squared minus X minus Y squared, then rad 5 thing rad 5 should be rad 5 plus rad 5 quantity squared. Good opportunity to mess up here and distribute the square, which is not a thing. Minus rad 5 minus rad 5, which of course is easy enough to do, squared. Well, this is 0 over here. Rad 5 plus rad 5 is 2 rad 5. I'm still squaring that. Squaring the 2, I get a 4. Squaring rad 5, I get a 5. 4 times 5. Boom, there's my answer, 20. Hey, getting some consistency. And finish it up. Which of the following describes the relationship between A and B as shown in the pair of numbers in the table above? Are A and B such, choice A, B equals A plus 4. Well, if I add 4 to 2, I don't end up with 5, so that one's not good. B is equal to 2 times A plus 1. All right, double it, add 1, that seemed to work. Double it, add 1, nope. 3 times A minus 1, triple it, subtract 1, triple it, subtract 1, nope. Square it and add 1. So 4 plus 1 is 5. It's gotta be because this one is squared and subtract 1, so that's not gonna work. Just for the fun of it, squaring it, adding 1, it seems all good. There's your homework. Have a good one.